This video contains the solutions to the vectors in the plane practice problems. For these first few problems, we're given 3 vectors in the plane. And this first one, we're asked to do some vector arithmetic. And the key thing to keep in mind when you're doing this kind of arithmetic is that everything happens component-wise. So if we want to know what w minus 3v plus u is, well, w is -1, 7, v is 0, 6, and then u is 3, -4. And we use the normal kind of order of operations we would do if these were numbers. So we do the multiplication first. So we'll multiply by the 3, and we multiply component-wise. That means that we take the 3 times the 0 and the 3 times the 6 to get our new vector. That gives us 0 and 18. And then when we're adding or subtracting vectors, we just take those operations in each component. So we take the first component of each vector, the -1, the 0, and the 3, and then we combine those to create the first component of our resulting vector. So -1 minus 0 plus 3, and then we do the same thing with the second components. With the 7 and the 18 and the -4, we just have 7 minus 18 plus -4, and then we just do that arithmetic. -1 minus 0 plus 3 is 2, and 7 minus 18 plus -4 is -15. And that's the result. Now we're asked to find a unit vector that points in the same direction as the vector u. And whenever we want to do this, whenever we want to find a unit vector that points in a particular direction, we take the vector that has the direction that we want, and we divide it by its magnitude. So if we take u and divide it by the magnitude of u, that will be the unit vector that we're looking for. So first things we need to do is that we have to find the magnitude of u. And the magnitude of u, and the magnitude of any vector, is the square root of the sum of the squares of its components. So 3 squared plus -4 squared, that's going to work out to be 25. The square root of 25 is 5. So the unit vector we're looking for is u divided by 5, which is the same as 1/5 times u. So that's 1/5 times the vector 3, -4, which is just going to be the vector 3/5, -4/5. And if we want to double check, we can take the magnitude of that new vector, and we'll see that the magnitude of that vector really is 1. And since it's a multiple of u, it points in the same direction as u. For this one, this question actually doesn't really have much to do with the specific vectors that we're talking about, but in general, if I want a vector that points from the head of u to the head of v, what do I do? Well, let's just draw 2 generic vectors and think about what that would be. If here's u and here's v, then the vector that we're looking for goes from the head of u to the head of v, and that's what we're trying to figure out. Well, we have a triangle rule set up here, so u plus the question mark vector is going to equal the vector v. That's how vector addition works. So that means that the vector that I'm looking for is just going to be v minus u. So the vector I want is v minus u, and now all we have to do is compute what that is with these vectors that we have. So v is 0, 6, u is 3, -4. So this is going to be 0 minus 3, and then 6 minus -4, which is going to be -3 and 10. All right, now we have a couple of word problems. So this one we have a suitcase with a strap where we're pulling on it at a 60-degree angle. So with these, it usually helps to draw a little bit of a picture. So I'm pulling on this suitcase at a 60-degree angle to the horizontal. So if this is my horizontal, that angle is 60 degrees. And the magnitude of the force that I exert on the suitcase is 40 pounds. So the length of that vector is 40 pounds. And I want the horizontal and vertical components of the force. So what I'm looking for is this horizontal component and this vertical component. And just to make these things a little bit easier to talk about, let's give these things names. Let's call them h and v. H for horizontal, v for vertical. So what we need to do is figure out what those components are, but what we should be able to tell right away is that because h is a horizontal vector, its y component is 0. And because v is a vertical vector, its x component is 0. So all we have to do is figure out what numbers go in those spaces, and it's easy to find the length of a horizontal or vertical vector because since one of the components is 0, the length is given by that other component. So if we can just figure out the lengths of those red and green vectors, then we'll be figuring out what numbers to put in those angle brackets. So really all we've got now is a trigonometry problem. We've got a right triangle with a 60-degree angle, and we know the hypotenuse is 40. So if this distance is, let's say, we'll just call it h without the vector hat and v without the vector hat, we know that, for example, the sine of 60 degrees is opposite over hypotenuse. That's going to be v over 40. Sine of 60 is the square root of 3 over 2. Multiply both sides by 40. That means that v is 20 times the square root of 3. Similarly, the cosine of 60 degrees is going to be h over 40. And not too hard to figure out that that's going to tell me that h is 20. So that means that I've figured out what numbers go in these brackets. Since the length of h is 20, h must be 20, 0. And since the length of v is 20 times the square root of 3, that vector is 0, 20 times the square root of 3. So those are the components that I'm looking for, and we're done. All right, in this question, we've got two vectors that are both acting on the same plane. So I'm going to draw a really rough plane here. Forgive my artistic skills, or lack thereof. And the plane is flying from east to west, which means it's flying in this direction at a speed of 320 miles per hour. And since that's traveling east, if we think of the sort of normal compass directions, where north is at the top, east is over here, south is down, and west is to the left, then we can think of that vector as being really easy to figure out. It's got a 320 horizontal component and a 0 vertical component. So that represents the velocity of the plane. But we also have a wind acting on this plane, and that's going in the southwest direction, which, based on our compass, would be going in this direction. And we know that the length of that vector is going to be 40 miles per hour. Now that one's a little harder to figure out because we have, it's not going in one of the cardinal directions, but we know that there's going to be a 45, 45, 90 right triangle here. And again, using just a little bit of trigonometry, we can figure that the length of this side is 20 times the square root of 2, and the length of this side is 20 times the square root of 2. So that means that the vector that represents the wind is just going to be negative 20 radical 2, comma, negative 20 radical 2. Because it's pointing down and to the left, both the x and y components are going to be negative. So what's the resulting direction of the plane? The plane is trying to fly east, but the wind is blowing it, so it's not going to be going directly east. The resulting vector for the plane, which maybe I'll call r for resulting, is going to be the plane's velocity plus the wind. We add those two vectors together to get the result. So that's just going to be the vector 320, 0, plus the vector negative 20 radical 2, negative 20 radical 2, which is just going to be 320 minus 20 radical 2, and then 20 radical 2. So that's the vector that indicates the direction and speed of the plane, but we're being asked for the actual speed rounded to the nearest whole number, which means we need to find the magnitude of that vector, which will be the square root of 320 minus 20 radical 2 squared plus negative 20 radical 2 squared. And when we put all that in our calculator, we end up with about 293.084. We're being asked to round to the nearest whole number, so that's going to be 293 miles per